so I'm going to do a few examples on solving linear systems by elimination. You guys said that when you hear the word eliminate, you think like get rid of it. What if it's a video game, destroy your opponent? Yeah, get rid of them. Okay, so. All right, so this first example, if you will just watch and listen, and then you can copy down the work. Okay, so the system of linear equations, it's still going to be set up like all of the other ones you've done. The only thing that has changed when we talk about systems is the method that we're using to solve it. So we used graphing to solve. That's where the lines that you graph, when they intersect, that is your solution. Remember, if they don't intersect, you have no solution. And then yesterday we talked about substitution, and this is the third and final method called elimination. So, do you guys remember in elementary when you would like add and subtract numbers like this? 6 minus 2 is 4. Yeah. You guys remember like setting that up? Or 4 plus 3 is 7. Okay, so you were reading it from the top to the bottom. Okay, we got to get in that mindset because that's how we're going to read, or not read. That's how we're going to work this using elimination. Okay, so I put my line under here, and we will be adding them together. Now, what do you think we're going to be eliminating? Yeah, one of the variables. So if we eliminate x, what variable do we solve for? Y. And then if we eliminate y, what variable do we solve for? X. Okay, so looking at that system, does anybody have any ideas as to which variable could be eliminated? Okay, Kay, why do you say y? Yeah, good, because you have opposites. You have the same number, but opposite signs. So here we have a positive 2y, and here we have a negative 2y. And if you add a number to its opposite, that gives you what? 0, good. And so by eliminating a variable, that means that it needs to, when you add them together, you will have 0, okay? So we're adding the top equation to the bottom. We'll start from left and let's go right. What's 3x plus 3x?
6x.
And then 2y minus 2y?
0.
Now remember, 2y plus a negative 2y, is that still 0? Okay. So remember, you can say it either way. I am going to say 2y minus 2y, but for those people who like to say this, then add the negative, you're still going to get 0. All right. So that's 0. We have eliminated that. And then what's 4 minus 4? 0. Okay. And that just so happens to end up like that. That's your constant will not always, when you add it to the other one, it won't always equal 0. Okay, so to solve for x, what is the last thing we need to do? Divide by 6 on both sides. 0 divided by 6 is?
0.
0. 0 divided by any number is 0. Okay? Now, we have the value of x. Now, what do we need to find in order to? Yeah, the value of y, because this is a linear system. Our solution, just like when graphing and using substitution, our solution is written how?
X and Y.
As an ordered pair. Yeah. You need your x value and you need your y value. So if we have what x equals, where do you think we're going to substitute this 0 to find what y is?
Where X is.
Where x is? Okay. Do you is it going to matter which equation we use? You don't think so?
Wait, yeah.
You want to check? You want to see?
It'll be the top.
Okay, let's see. So if I substitute 0 into the top equation,
It equals out.
y is 2. If I put it in the second equation, I can cut out parts of the video just so you know. Okay. Negative 2y equals negative 4 divided by negative 2. What does y equal? So does it matter? Does not matter. Do you guys remember how, you might have your own process that you go through to work specific problems? For example, like word problems, my process every single time is to draw my chart and then look for that information. Or remember the slope formula. What was my very first thing I always did? Remember? Yes, and then what was the first thing I did after that? I put what where? There was something I always did first. Put parentheses where the variables were. So, huh? So I do that every time. That's my process. So here, my personal process is, once I solve for one of the variables, I just go back to the top one every time. But that's a personal preference. You can go to the bottom one every time, but you need to figure out some routine. That's the word. Some routine that you can do for each of these. Okay. So what's our ordered pair? 0, 2. Are we done, or do we need to check that? We need to check it. Do we check it in just one or both equations? Yes. Because remember, it can check out in one, but not check out in the other. Okay, one very important thing. When you get your solution and you need to check it, you're substituting that ordered pair back into the original equations. When I mean original, I mean the problem that's written on your paper, those equations, like the problem that you start with. Okay? So, let's see, x is 0 and y is 2. Four equals 4. That is a true statement. negative 4 equals negative 4. That is a true statement. Okay, so here's example 2. I like to go ahead and draw my line underneath to get in that frame of mind. Going to be adding them together. Now on example 1, we already had a variable that could be eliminated. It was that y term, okay? Because here we had a positive 2y and a negative 2y. So therefore, if you have the same coefficient but opposite signs, that means that you can eliminate that. So this one we were already set up to eliminate that y term. Here, are we already set up to eliminate something here like x or y? Okay, so let's look at the x terms. In that top equation we have negative 10x. In the bottom equation we have negative 5x. Are those coefficients opposites of each other? Okay, what do you mean by saying? Okay, but what's the opposite of positive 6? Negative 6. What's the opposite of 100? What's the opposite of negative 5?
Positive.
What do you notice about those pairs of numbers?
The same number.
It's the same number, different signs. So if you're looking at the x terms, is negative 10 and negative 5, are those opposites? Are they the same number? No. Okay. What about the 3 and the negative 6? Are those opposites of each other? No. If it helps you, write this down. Okay, opposites. It's same number, different sign. So, opposite of 3 is negative 3. Okay, opposite of 7 is negative 7. Opposite of negative 6 is positive 6. So that might give you sort of like a reference. All right, so if we don't have any coefficients that can just be eliminated right now, I mean, what do you think we're going to have to do to make that happen? I will tell you that it's something that can be done to an entire equation. Multiply what? Yes, that's what you're going to do. So take what you said and look up here. Do you think you're going to have to choose to eliminate x or y, because you can only do one at a time? Which one do you want to do first?
Let's see, we can do x.
Okay. So what do you notice about the negative 10 and the negative 5?
They're both, you can divide them by 5, or multiply them by, no, 2. No.
You can divide. I like how you said divide them by 5.
Yeah.
So 10 is a multiple of 5, because 5 times 2 is 10. Okay. So what do you think? Which equation would we multiply? What number would we multiply it by?
I don't know if you could do it for negative 10x, because that would make 3 6. But would you do it?
But you want to eliminate x, remember?
I said you did it to negative 5.
So if you want to eliminate x, don't worry about the y's. So just look at these two numbers. What would have to happen to eliminate the x terms?
Your 5 would have to become 10.
Negative 10 or positive 10?
Negative, no, positive.
Positive, because we have a negative 10 here. Negative 10 plus 10 is 0. Okay. So, Tyler, how do you think I'm going to show multiplication in the entire equation? Do what? Okay, if I did on the sides, what's some like symbol I can use to show that I'm multiplying the entire thing? Okay.
Parentheses.
Yeah, parentheses. Good. Okay. But you are right. A dot does show multiplication. But remember the distributive property. The distributive property. Okay. If you have a number multiplied by some expression like x plus 1, we know to distribute because the parentheses are around what? X plus 1. And so that tells us, well, I have to multiply 2 by the x, and I have to multiply 2 by the 1. Okay? Same concept. So, you would put parentheses around the entire equation that you're going to multiply a number to. Which number will we multiply by, Haley?
2.
Okay, so 2.
Negative 2.
Okay, why'd you change?
Because you have to make the negative 5, you have to make it positive so that they can be different.
And so a negative times a negative is
A positive.
a positive. Good. So we would need to multiply that bottom equation by negative 2 because Anna chose to eliminate the x terms. So the top x term is negative 10x. If we want to eliminate that, that means the bottom x term has to be positive 10x. Okay? So you distribute that negative 2 to the entire equation, even over the equal sign. Okay, I know it looks kind of funny, but all right. Now, you're going to have to do some rewriting. I'm going to rewrite that top one and then write my modified bottom equation here. So negative 2 times negative 5x is what? Positive 10x. Negative 2 times negative 6y. Positive 12y. And then negative 2 times 23. Negative 46. Negative 46. Okay? Georgia, do you see one of the variables that we can get rid of now?
You can do plus 10x on the side.
Okay, we're reading it. I forgot to put my line here. We're going from here down. So you see how the x's line up, the y's line up, and then equal sign constant. So you're looking at this x term. You're going to look at the one below it to compare. Okay, do you have any variables that have the same number multiplied by them but opposite signs? Yeah, good. So there's negative 10 on the top and then 10 on the bottom. So if we add those, what's negative 10x plus 10x? 0. So we've eliminated that x term. Okay. Okay, so what do we do here? Which would be 15y. Yeah, 3y plus 12y is 15y. And then what about 1 minus 46? Negative what? Negative 45. Remember, if you have opposite signs and you're adding, you actually subtract the numbers and keep the sign of the larger, which would be the 46. So negative 45. Then we're going to divide by 15 because we're solving for what variable here?
So y.
We're solving for y. Okay. Yeah, I'll probably cut that part of the video out. Okay. All right, so y equals what? Negative 3. Good. So now that we have what y equals, where do we substitute negative 3? Into an original equation. Okay. Huh? Yeah, so when I mean original, like let's say, the homework I gave you, number 1, you have a system written there. Those would be the original equations, okay, before you did anything to them. So we're going to take negative 3 and substitute that in to one of the original. But I told you I like to substitute it into the top one, but you don't have to do that. What was the top equation?
Negative 10x plus 3y equals 1.
Negative 5x minus 6y.
Okay, so since we solved for y, I'm going to take that y value and I'm going to put it where y is in one of the original, okay? You could have chosen that bottom one. It wouldn't matter. No, it's okay. Okay, so negative 10x plus 3 times negative 3 equals 1. Negative 10x minus 9 equals 1. Negative 10. What does x equal? Negative 1. So x equals negative 1. So as of right now, what are we thinking our solution is? What ordered pair? Negative 1, negative 3. Good. What are we going to do to check that? Yes, you're going to substitute it into both original equations. Good. Both original equations. So, well, I already have one right there. So I'm going to use, remember this is your x value. That's your y value. I'm going to substitute those in. All right, that's a true statement, so we know that it checks in that equation. What was the other?
Negative 5x minus 6y equals 23.
Okay, so negative 5x, so negative 5 times negative 1 minus 6y, so I'm going to put negative 3 here. Negative 5 times negative 1 is positive 5. Negative 6 times negative 3 is positive 18. And 5 plus 18 is 23. So 23 equals 23. And that's a true statement as well. So our solution here is correct. All right, does anybody have a question?
I don't know how to.
Which part? which part are you looking at?
That part.
The check?
Yeah.
Okay, which one? The first one or the second one?
Both.
Okay, so remember whenever you're checking, you're putting those values in for, X and Y. It's not like solving an equation where you're trying to find what the variable is. So you're not going to be moving anything to opposite sides. You're literally going to simplify both sides of that until you get to the very bottom where you have some statement here. Okay? So the original equation was negative 10x, that's my x, plus 3y, negative 3 is y, and then you have to, have equals 1. Negative 10 times negative 1 is positive 10. 3 times negative 3 is negative 9, and then 10 minus 9 is 1. But you can use your calculator, and if you put it in exactly like this here, it'll give you 1. Okay. So like if you're on a test and you run out of time, I understand if for some of them you might have to just put this in the calculator to get, what one side equals. Okay. All right, so we started with a system where there was already a variable that could be eliminated, where it was just given. Then we went to example 2, where one of the equations had to be multiplied by some number. Okay, where do you think we're going to next? Good, where both of them have to be multiplied by some number. Okay? Okay, I'm going to rush through this one. We don't have much
Wait, do we still need a copy now?
time. Yes. Okay. I'm gonna do a think aloud. I'm gonna talk my way through this one, so you guys can copy as I write. Okay. Oh wait. Okay, so earlier Kaylee was looking at her homework. She's like, well, none of the coefficients are the same, and so whenever you look at these, draw my line. Is there anything we can multiply by 12 to give us 8?
No.
Is there anything we can multiply by 8 to give us 12? No, and we're not going to be multiplying by fractions or anything like that, because that's technically division. We're not going to do that. Is there anything we can multiply by negative 7 to give us 11, and then 11 to give us negative 7? No, so, because you would have to multiply one of the equations by some number. So if you go through that process, that is telling you that you're going to have to multiply both equations by a number. You guys are writing, okay? I should write this down. All right. I'm going to choose X to eliminate. I see that I have a 12 and an 8, and you're going to find the least common multiple. So the smallest number that both of those can go into is 24. What times 12 gives 24? 2. And then what times 8 gives 24? 3. Now, one of these has to be negative, right? So that means that either the 2 has to be negative or the 3 has to be negative. Okay? I'm going to say, I'm going to multiply by positive 2 here. And then what am I going to multiply here? -3. Good. 2 times 12x is 24x. 2 times -7y is -14y. And 2 times -2 is -4. -3 times 8x is -24x. -3 times 11y is -33y. And then -3 times 30 is -90. Okay? Going to add those together. 24x minus 24x is 0. Good. Then -14y plus a -33y is a -47y. -4 plus -90 is -94. Divide by -47. Y equals 2. I think 2. So I have my y value. I'm going to take that and substitute it into one of the top equations. One of the original, excuse me. So 12x minus 7 times 2, is that right? Equals what? Equals -2. Alright, so 12x minus 14 equals -2. Add 14. 12x equals 12. 12. X equals 1. So, as of right now, that is the ordered pair that I am finding to be the solution. Now I need to check it in both original. Okay? Whew. Great job, guys.
Then it's like, why does
That made my. Okay, so now we have our ordered pair, and we need to figure out if it really is the solution. So you're going to substitute that in to both original equations. So 12x, that'd be 12 times 1 minus 7 times 2 equals -2. 12 minus 14 equals -2. -2 equals -2. That checks. Let's check the next one. 8 times 1 plus 11 times 2 equals 30. 8 plus 22 equals 30. 30 equals 30. And that checks as well. So we know that that solution is correct. You're watching this video, just a reminder, your homework for 5.3 is numbers 2 through 16 even, and also number 17.